Good evening, and welcome back to the live series of webinars, part of the wider live series that we host here at Amicus Recruitment. Those of you who don't know me, I'm Jamie Crowley. I specialise in recruiting across the JavaScript market within the UK and also remotely for businesses that are based in London. So I'm today joined by Bertalan Eck, who's one of the senior engineers over at Babylon, and he's going to be giving us a talk on Serverless GraphQL API with AWS CDK. Now, this session is aimed to be really interactive. So Bertalan has registered little slots in his presentation where we'll be able to ask questions. So at any point throughout the presentation, if you have any questions that you want to ask to Bertalan about either the specific topic he's talking about or the wider serverless GraphQL API sort of thing, please feel free to ask away and I'll manage that and make sure all your questions get answered. But I think from me, that's probably enough. Bertalan, thanks a lot for joining us. And yeah, feel free to take over whenever you're ready.
Sure, thank you very much, Jamie. Good evening, ladies and gentlemen. I'm going to just share my screen quickly. Can you guys see my screen?
Yeah, all good. Perfect.
Cool, thank you very much. Yeah, so my name is Bertalan Eck. I'm a senior software engineer. I've been working with JavaScript and TypeScript over the past 5 years or so. And I'm quite a big fan of serverless and AWS as well. So I'm really happy to be here today to talk about all this kind of stuff. Today I will be talking about serverless computing in AWS, and then we will focus on AWS Lambda, which is the heart of the whole serverless features in AWS, and then I will move on to GraphQL and AppSync. I will be also talking about infrastructure as code, AWS CDK in particular, and then we'll create a GraphQL API with AppSync and CDK. So first of all, I would like to talk about the problem that serverless computing tries to solve. So in this picture here, you can see a traditional way of handling requests and making sure that there's high availability, scalability, robustness in a system. So you have Amazon EC2 instances, which are basically just bare minimum servers within OS on them, and you would attach those into a auto-scaling group, and you would have an elastic load balancer in front. So based on the demand, the auto-scaling group would spin up and spin down instances, trying to meet your services demand, but it will obviously take some time for it to spin down new instances and spin down new ones as well. You will also need to make sure that those instances are provisioned properly and that they have your services running. But mostly the problem with this is you just can't really determine the demand for your service. So it's really common that developers over or under provision for a particular service. Is actually more common to over provision it to make sure that it's available. So the whole point about serverless computing is to build and run applications without thinking about server. And AWS, the serverless technologies, can actually do that for you. There are trade-offs. I'm not going to go into all of those during this session, but basically what you can achieve with serverless is automatic scaling, high availability, pay-for-use billing, decreased infrastructure management overhead, and you would have over 200 AWS services. As I said, the heart of the serverless world is AWS Lambda, which is basically a event-driven pay-as-you-go compute service. You are billed per millisecond, which is awesome. It basically runs your code without provisioning or managing infrastructure. The developers would be just like, here's my zip, upload it to AWS, and there you go, just run it for me. I don't care how you do it. I don't care how many instances you run. I don't care if I have just a couple of requests per day or I have a million requests per day. You just take care of all of that. And basically that's what it does. It can respond to high demand in a double-digit milliseconds, which is definitely something that auto-scaling groups can't do. The most typical use cases for serverless and AWS Lambda are developer environments. You wouldn't want to run servers overnight when nobody is using them. Second one is unpredictable traffic. When you have spiky traffics, or you have basically you just can't really determine how the service will be used. So when you send out lots of newsletters, for example, then you might predict that there's going to be some demand, but in most cases, maybe there just isn't much going on. Then there's quick scaling and cost savings, file processing, data analytics, and event-driven systems. You can do all of these things with AWS services, AWS serverless at a reduced cost. So I'm going to talk about how AWS Lambda works. So basically, developers can't access Lambda functions directly because, as I said before, they are event-based. So there must be a trigger that fires a Lambda functions. A good point is that AWS only runs your functions when you need it. So you just only paid for the time that it runs. When a function is triggered, then the event is passed to the Lambda function, and the shape of that event is based on the service that triggered it. We will be talking about this in more detail just a bit later. I would also like to talk about cold and hot starts, because that's really, really important stuff about AWS Lambdas, and that's one of the trade-offs that I need to mention. So when a new instance is fired by AWS, there's going to be a cold start, which means that it's going to be slower than the consecutive calls on the same instance. That is definitely something that developers need to take into account. It might not be that bad. It might be just around a couple of 100 milliseconds, but if you're not careful, it can be even 2-3 seconds or more than that. And that's not a really good user experience. So watch out for the cold starts. The Lambda function handler is the method that processes the event. So basically, we are talking about here JavaScript today, and this is an example code how really, really simple a Lambda function looks like. It exports a handler function, and in this particular case, this is just lists all the S3 bucket that the AWS account has. It's really, really simple actually, and no need to worry about servers. That's the whole part of it. As I said before, there are over 200 triggers. I won't be talking about all of those, but I would like to mention 5 most common use cases. The first is when an object is uploaded to the simple storage service, AWS S3. Imagine that a user uploads an image, and then a Lambda function is triggered, and then you get to resize it or make some enhancements on it or create duplicates or do some image processing, whatever you want. It's all asynchronous, and it's all just runs when a new image is uploaded. Second one is the API gateway, which is mostly used for REST APIs. So if you want to have its serverless REST APIs with Lambdas, then you would need an API gateway in front. The third one is Event Bridge, which is basically a serverless event bus system. You can emit certain events and then you can listen to those in Lambda functions. One of the use cases with that, which I've used as well, are cron jobs. You can define cron jobs using Event Bridge and AWS Lambda. The next one is the simple queue service. You can have a SQS in AWS, and when you add like a new messaging into the queue, a Lambda function can be triggered and just deal with the message basically, and it's all really serverless. I would highlight though that there would be SQS polling going behind the scenes, but it's all taken care of by AWS Lambda, so you don't need to worry about that. And the last one is AppSync, which is a managed GraphQL service. We will be talking about that later in this session. I would like to share an example users app. Obviously, this is just a bare minimum, and I just hope that you guys can have a sentiment of how this works. So as I said, if you want to have a serverless REST API, you would need to have an API gateway. And in this case, we have 4 Lambda functions. Once you create, update, read, and delete users, and they all basically interact with the same users table. And as you can see, your clients can be just anything, a mobile app, a desktop app, a TV even, whatever you want. As I said before, Lambda is based on events, and when somebody makes a request to the AWS gateway, then this is the event object that's actually passed into the Lambda function. So we can see that how easy it is to write a business logic on top of these events. You have access to the headers, the cookies, the path, and the crediting parameters, and there's a lot more which I didn't put in this picture, but it's capable of doing a lot more. And I would like to share a graph of one of my production services. This service basically returns share price for a UK website, and this is the invocations graph from last week. So you can see that it is quite a spiky traffic. It varies, so it would be quite difficult to provision services for this sort of demand. Most of the time they would be over provisioned. You can also see that around the 30th of March, that overnight we just had around like 2,500 invocations, and then around like 8 a.m. in the morning, the next day we had 10,000 invocations. And I don't need to worry about scalability because AWS Lambda takes care of it for me. I'm going to stop for a while to see if there are any questions at all.
Perfect. So we've not had any come through on the Q&A section. So if anyone does have any questions, feel free to put them in either the chat box at the bottom, or you can use the Q&A section. I did see someone raise their hand, so I don't know whether that was a mistake or whether they were looking to ask a question, but we'll stop here for 30 seconds. If anyone's got any questions for Bertalan, then let me know and we'll get them answered for you. James, I just saw your hand go up there as well, so if you have got a question, feel free to get it in. Don't worry if we don't get answered in this section, we'll have another break throughout the webinar or at the end to make sure that your question gets answered. but there's nothing come through for now. Oh, here we go. Just got 2 through, like London buses. 3, right? 3 questions for you. So, first one from Tonas. How can serverless be set up for local development?
Oh, well, that's a really good question. So there are several ways to do this, and I think it would be worth an entire session. But basically, there's this website which is called serverless-stack.com, which is really good at actually doing this. And also AWS has a couple of Docker containers, which is called local stack or something like that. So you get to like emulate AWS Lambda. And there's also serverless.com, where you can basically invoke functions locally. It's really cool. Yeah, so there are a couple of choices there.
Brilliant, thank you very much. Another one through from Joseph. Do you have any experience with Lambdas in containers, and do they tend to be slower?
Not yet. I'll be honest with you. I've been just using it with the zip packages, not with containers.
Okay, no problem. And Pablo has asked, are there any scalability considerations at all with Lambdas?
Yes, so most of the AWS services come with a certain limitation of quotas. So I think it is like, off the top of my head, I think it's 3,000 concurrent instances per Lambda, but I'm not sure. But yeah, there are definitely some sort of limitations.
Perfect.
Yeah, feel free to take a look at AWS docs on it, because there are some, but it can be lifted as well.
Brilliant. I think someone's actually just put a link into it. So thanks, Kevin, for putting a link in the chat if anyone wants to have a look at that. So I think that's all the questions we've got for now. So feel free to carry on, Bertalan, and we can always have another stop for any other questions.
Okay, thank you. So we are moving on to a GraphQL topic. I'm not sure how many of you have used it, so I will be really brief and just basically trying to introduce it for those who have not come across with it yet. So GraphQL is a query language for APIs and also a runtime to fulfill those queries. What is really, really good about it is that you just need to ask for what you need, nothing more or less, and then you get exactly back what you asked for. You can also get many resources in a single request. So going back to the REST API, you would not need to make 2 or 3 consecutive requests to get something, or even parallel requests to get something. You can just do everything in one. And what is also really good about it is that it's already strictly typed, and developers get to have a complete and understandable description of the data. I will talk about this in detail shortly. So a GraphQL service is created by defining types and fields, which are then combined called schema, and clients send queries to the GraphQL API in an HTTP POST request. And then the GraphQL API resolves the query and returns a JSON response. Here is a really, really simple example of this. So we have a type definition. We have a user type, which is 2 fields, ID and name. Name has a type of string, and ID has a special a built-in type called ID. And then we also have the query defined, which is called me. In this case, it basically wants to mean that it is going to return the logged in user. And then the query is really, really simple. It's a JSON-like query, and you just send the name of the query that you want, which is me, and then in braces, in brackets, then you just list the fields that you want to get back from the API. So you can see that the response is, it basically has the same structure as the query. We did not ask for the ID, so it's not in the response. And there is just one more example for a bit more complicated type, which we'll be working with in the end of this session. So this is basically an address type. I was trying to mimic a UK address types when we have where we're going to have an ID, but we have address line 1, 2, and 3, a town, and a postcode. And the difference here compared to the previous one is that you can see exclamation marks. Basically, they mean that those fields will be there when you ask for them. They cannot be null. If you ask for line 1 for an address, it will be there. And if you go down, and if we go down to the queries, we can see that there are 2 queries. One which is called list addresses. It's going to return an array of addresses. It has 2 exclamation marks because the first one means that every item in the array will be an address and it cannot be null. And the second one, the outer exclamation marks, mean that altogether list addresses query must return and will return an array, not a null. A second query, okay, so I can see a question mark means mandatory. Yes, it means mandatory from the API perspective that it must return it. And if it's not there for whatever reasons, then it's going to throw you an error. So the second type, so the second query, which is find address by ID, when we get to pass in a parameter, an ID, and then it will return an address. Well, this one does not have the exclamation mark because we might not have the address for that particular ID. And on the right-hand side, there are a couple of there are examples for each one of those, how we get to query basically these queries that we have. And now we can see the response for these queries. So the list addresses will return an array, as I said, and then obviously every item in that array will be an address. And we can see here that we just ask for ID line 1, 2, and postcode, that this one also just has these ones. And in that case, line 2 was nullable, so we got null in this case. I'm sorry. And then when it comes to the find address by ID, as I said, it could be null. In this case, we're just going to have a null. Or if we've it found the address, then we're going to have an object. And now I'm going to talk about AWS AppSync. I mean, I hope that this was enough for you to kind of get an understanding about GraphQL and how that works. AWS AppSync is a managed GraphQL service. It's serverless, so it basically scales with the demand. It's simple, and it gives you secure access to AWS services. As I said, there are no servers to manage at all. And why I think is really cool is because we get to attach AWS integrations to resolve queries and types. So if I'm going to have like a good picture about it. Here it is. So basically, if you see that AWS AppSync could be like a huge API that has access to many microservices under the hood. And those microservices could be either in AWS Lambdas, they could be a REST API, or whatever you want. It basically gives you a gateway to access all those services. And when you define your API, then you get to choose that this particular query will use an AWS Lambda function to resolve, and that other query will use a REST API to use. And it's all basically hidden from the clients. They can just only see the GraphQL API itself. I'm going to stop here again to see if there are any questions.
Perfect. Yes, we do have one that's just come through from Nicholas. So he's going back to the question of how can serverless be set up for local development. He's mentioned using serverless offline plugins such as serverless offline SSM, serverless offline, serverless Webpack, etc. Are they considered as good practice?
Yes, I think they are. As I said, there are many ways to actually do this. One way is definitely to use those plugins. So if you go to serverless.com, this is the whole kind of framework that lets developers work locally with serverless, and it comes with many to So feel free to use them. It's good.
Perfect. Nothing else come through. Oh, there's just one more here actually. So Federica has asked, is AWS Sync a good substitute for Kubernetes?
Well, this is a tricky question. So Kubernetes is obviously a service to manage containers. AWS AppSync does not manage containers. So I think the question would rather be, is AWS a service or Lambda in particular good to replace Kubernetes? I would say that yes, but there are trade-offs obviously. So it would need further investigation to see if it's a good fit for your use case.
Brilliant. We've just got one more, if that's okay, Bertalan, from David, who said, can you do a federated GQL service with AppSync?
No, you can't at the moment, I think. And the reason for that is because the federated GraphQL concept is Apollo's creature. So if you want to use federated graph, then you would need to have an Apollo server that is able to deal with all of those things. At least to my knowledge, I don't think it's able to do it because it's not a built-in GraphQL thing. It's a concept of Apollo, which is a standalone company.
Perfect. Yeah, brilliant. That's all of them for now. Thank you. So yeah, feel free to carry
on. I would like to talk about infrastructure as code. So first of all, the good thing about infrastructure as code is that you actually get to use code to manage and provision your infrastructure, as opposed to AWS console, for example. It is the single source of truth, which makes it easier to onboard new developers. And why I really like it is because it makes it easier to do deployments when you have several AWS accounts and several regions. If you have used AWS console before, you know that, or just AWS in general, you know that actually configuring your infrastructure in AWS is quite cumbersome. And if you just basically do that all in the console, clicking through the GUI, you can easily forget about the tiny intricacies and how certain things are set up. And when you have all that as code, then you can just basically look at it and find out, you know, what you did, why you did it. So it's a really good practice, I think. There is one big guy in this area, and they call Terraform. It's a product of HashiCorp, and it is a really good tool to do infrastructure as code. They are using their own language actually to do this, and I would recommend it for those who have hybrid cloud use cases. So when you don't just use AWS, but you use GCP or Cloudflare and so on. Terraform has plugins for most of these providers, and you can just easily have everything in one repo, in one particular stack. And the second one is AWS CloudFormation, which is basically how AWS has started its infrastructure as code journey. It uses a YAML file to create stacks for you, which is also nice in some way, but you can end up having huge YAML files, and it's not that easy to see through and make changes to it. So that's why I will be talking about AWS Cloud Development Kit, CDK, which is an open source development framework to define cloud applications resources using different programming languages, JavaScript, TypeScript, Python, Java, and so on. And it uses cloud formations behind the scenes. And what I really like about it is that it's testable. So when you have like a Lambda function that needs access to AWS S3 or DynamoDB, then you can write a unit test to see if this particular Lambda function does have access to that or not, which I think is really cool. And if you want to stick to, for whatever reason, a CloudFormation YAML files, you can make a YAML file based off the code. And now we're gonna look into creating a serverless GraphQL API with AppSync and CDK. And I will use the address schema that I have showed before. I have saved it into a schema.graphql file, and we are going to use TypeScript for this particular example. And we will also have Lambda handler functions created in TypeScript. This is going to be really high level and just really small example for you to understand how it works and how easy it is to actually set it up. So here's some TypeScript code. This is more or less the bare minimum to get started. Basically, you will need to install AWS CDK core and AWS CDK AWS AppSync in order to define a new GraphQL API. So you can see that from line 8 to 11, that's where a new GraphQL API is created. It first takes a stack, so this is passed on, and then it gets an ID, which is up to you to defined, and it takes a name, and it takes a schema, which it's reading from this schema.graphql file, which I just created based off the address types that we have. So the next bit would be to actually add some sort of authorization to this API. And for this example, I choose an API key. You can see how easy it is to set this up in this particular way. You can create a API key within the code that will be valid for 365 days. You can obviously go lower on that if you wanted to. And there are also like a lot of other ways to do authorization on it. You can use the cognito pool, so you can absolutely fine-grain like even which types users would have access to in queries, which is really cool. And then this is the Lambda handler, which is going to return all the addresses that we have in our database. So now it's obviously hard-coded and it's just one element in this array, but that's the way how we can actually do this. Obviously, if we had like a DynamoDB database and if we need to have access to that, we could put all that code into here. And then when we deploy our CDK stack, it will also create the Lambda function for us. And this is the really interesting bit when we are going to attach the Lambda handler to the GraphQL query. So basically, from line 15 to 23, this is where we create a new Lambda function, and it will be a Node.js Lambda function, and it's going to use the code locally. The functions folder and the list address.ts file, and it's going to use this particular handler function to do the code, to do the business logic for us. And what we need to do basically is to tell AWS AppSync that we have this query, we have this Lambda, and now we have to marry the two together. And this is basically what happens from line 25 to 33. We are actually saying that let's have a Lambda data source, and that data source is going to resolve the list addresses query that we have in our schema. So that's it basically. You can see it's only 34 lines of code, and you have a fully serverless service. And if we wanted to deploy our stack, first we need to build the TypeScript files, obviously, and we can use the CDK thint to get the CloudFormation YAML file if you need it, or you can just simply run CDK deploy, and it will do the deployment for you. And if you no longer need the stack, you can destroy it with CDK destroy. Well, thank you very much for your attention. That's what I wanted to talk about today. Feel free to fire away any questions you may have.
Thanks a lot, Bertalan. That was brilliant. We'll just stick around for another 30 seconds or so, just let anyone get in any questions that they've got as well. What I just wanted to mention at this point as well, just while we are waiting for questions, Bertalan asked this before, and I know a couple of you have as well. Anyone that wasn't able to make it tonight, whether that's any friends or colleagues that you passed the webinar on to, it will be going live on YouTube as of tomorrow. So I'll make sure to send this out to everyone who attended, see if they've got a recollection of it there as well. In terms of questions from Paul, we've got, would you be able to provide a GitHub link to the sample project?
Well, I can't provide it now, but I'm happy to upload it there for you. Okay.
Yeah, I was going to say, if you want to maybe send that to me tomorrow, Bertalan, and then anyone that's interested in receiving that, yeah, feel free to get in touch with me, and I can send you the repository, so you can have a look at it there. Any other questions before we get wrapped up? No, I think we're all good. Well, really appreciate your time, Bertalan. That was really, really good talk. Lots of questions coming through, and hopefully everyone else enjoyed it as much as I did. And Bertalan, like I say, really, really good talk. So thanks a lot for taking the time out of your busy schedule to deliver that to us. Lots of thank yous coming through from everyone in the chat as well, which is always really good to see. So yeah, thanks a lot again for joining. Everyone who's not been able to make it today, like I say, it will be on YouTube as of tomorrow. So feel free to get in touch there and have a look through, and maybe watch one or two of the other ones that we've done as well. If there is a talk that you want to do in the future yourself, so anyone in attendance who is looking to do a chat themselves, wants to do a presentation similar to the one that Bertalan has just done, feel free to reach out to me on email, LinkedIn, anywhere that you like, and we'll be able to set that up for you as well. But all I will say, Bertalan, is there's a lot of thank yous coming through, so I'm sure everyone really enjoyed that, which is really, really good to see. So yeah, thanks again for your time, and I'll speak to you soon.
Thank you very much for having me today, Jamie.
No problem. Thanks a lot, everyone. See you soon.
Thank you. See you guys all. Bye-bye.
Bye-bye.